Hello everybody and welcome back to Wi-Fi Sheep at Christmas with me, Tom, and this, which is day 14, it's December the 14th, 2022, and we're continuing with our daily Electronics Games Advent Calendar build project. So last time we had set up our circuit and we were doing a bit of code breaking. And I can't remember the code. What was the code from yesterday? No. That was it. Yeah. Which, yeah, it was all right. Did the job. Worked. So that was day 13. Let's turn this off. So let's take a look at the Advent Calendar itself. And where are we? Day 14. Here we are. Door number 14 here. I'm going to try to do this without using a screwdriver. Okay. Where's my now broken screwdriver? This is very elegant. Right, there we go. Day 14. Why, it's yet another resistor. Let's consult the book. And we want day 14. Day 14. Here we are. Tennis trainer. Behind door number 14, there's a 22k ohm resistor. Red, orange. Yes, I can confirm that is red, orange, which allows selection of another program. This time it's a simple table tennis training game. Press the left button to hit your ball. Your opponent is the computer, which hits the ball back over again. Okay. Okay, I've done something very similar to this with Tiny Basic, which I don't think I've ever shown you on the channel. It was done for a commercial client. Hang on a minute, I've actually got it with me. Yeah, so basically this is what I built. This was a daughter board for our Tiny Basic computer module. It's done for a third-party client. And it was a back and forth Pong type game based on the Altair Pong that was played on the front panel of the system. And you had a row of diodes that went back and forth to simulate the ball. And that's exactly what this is trying to emulate. So yeah, okay. So I know what this is going to be. So this will be very interesting to see how well this works. So to make that happen, we need to. What are we doing then? We change it. What are we doing? Okay. Right. So that diode goes out. This diode is going in onto the selector. It's quite clever how it does it via voltage rather than on off up down pull logic, 0 or 1 1 0. It's measuring a variable between 0 and 225, I'm guessing, and then it's selecting the program from that. So it's actually only using one pin for selecting, I think, which is kind of smart. Anyway, right. And then we've got to put our LEDs back in. Trying to get these in the right way. And it's, where are we? Short leg to the top. So that's red. Green. Has the yellow gone walkies? Where's yellow gone? Oh, it's there. That's the other thing I'm finding with this. It's all the bits sort of start going walkies. It's not so much a problem because I've got replacements, but I think for anyone else that might be hang on, let's put that in there. So there we go, and get them to sort of sit like that. Is that all we have to change? I think it is. Okay, I think we're ready to try this then. So no, I'm confused. Am I playing? Okay, what's that mean? A bit more logic in this one than my version. Oh, I see. I'm playing as a one-person game. Okay, I've got it now. I'm playing as a one-person against the computer. But in that scenario, how does the computer ever lose? If I don't do anything. Yeah, okay. Nope. It's a very slow game. And that just keeps running until we... okay, right, I've got how that works. So, let's just do a quick read up on this. So, press the left button to hit your ball. Your opponent is the computer, which hits the ball back over and over again. The position of the ball is indicated by the 4 LEDs. Yep. When the ball comes back to the left side, you need to hit the ball again at exactly the right moment. A high-pitched sound will be heard when you hit the ball. If you miss the ball, the lower-pitched sound will be heard. The computer jumps into action on the right-hand side and automatically hits the ball back. If you press the right-hand button at that moment, the game will stop and the ball will stay on the right. Yeah, we have that. Push the right-hand button again to restart the training session. That's why it says trainer. It's not a full game, so the computer can't ever lose, basically. Oh. Yeah. Oh. Okay. Well, that's interesting, and it's a different take on the circuit that I actually built. I'll just bring that back in. They said mine actually had more LEDs on board, similar size breadboard though. So mine had more LEDs on board. However, their game logic perhaps a little bit better than mine. Mine was a 2-player game, so there's no computer involved, so it was 1 player versus 2, back and forth. But the snag of my version was if you could hold the buttons down, it would identify it as being hit and it would just bounce back and forth like that indefinitely, which was something I never got around to fixing in just 1K of RAM. So yeah, okay, that's rather interesting. So I wonder if we're going to develop on this tomorrow. It's quite possible. So that was day 14 right here on Wi-Fi Sheep at Christmas. If you haven't done so already, please do consider liking and subscribing. And I guess I'll see you tomorrow. Until then, Merry Christmas and bye for now.